All right, guys, so this is the notes for chemistry and matter. And so we're going to start off with just a definition of chemistry, okay? We're in week 4, so it's about time that we defined what chemistry is. So chemistry is the study of matter. The study of matter, okay? That's it. But that doesn't really help you if you don't know what matter is. So we're going to go ahead and define matter. Okay? Matter is anything that has mass and volume. Anything that has mass and volume. Okay, mass and volume. Now, if these words aren't familiar to you, make sure that you put yourself a note so that you know what mass and volume are. Mass means it weighs something, okay? You can weigh it. Volume means it takes up space. If you were to tell a little kid that something has volume, they're going to have no idea what you're talking about. So you would tell them it takes up space, okay? So the more space it takes up, the more volume that it has. Okay, we're going to make a flow chart for matter, and we're going to split it into 2 main categories, and then we're going to split each of those categories into 2 more categories. So I'm going to erase these 2 definitions. If you need to pause the video, do so. I'm going to erase these to make room for the flow chart. Okay. Again, if you're confused about where you're supposed to be writing these, they should be in your notes so that you have them for the test and you can use them on the test. Okay? So up at the top of my flow chart, I've got matter. I'm going to go ahead and split that into 2 categories. This left category, I'm going to write pure substances. Pure substances. And the right category is mixtures. Mixtures. Okay? Now we're going to define each of these before we split them further. So a pure substance always has the same composition. Always has the same composition. Pure substances always have the same composition. You can write a formula for it or a symbol for it. So you can write a symbol or a formula for it. Okay, remember, a symbol is one of those on the periodic table. A formula just has more than one of those put together. Okay? All right, mixtures. Mixtures, the things in it the things it is made of can change, and the ratio of the things can change. Okay? Things it is made of and the ratio of these things can change. The things it's made of and the ratio of things can change. So for example, salt water. Salt water could be really salty or not really salty, but it's still salt water. That's changing the ratio. Another thing that you could do is change the type of salt. You use table salt, salt water, or you could have sea salt, salt water. And so the type of things changes as well, and it's still salt water. So that's a mixture, okay? It's not a defined thing. Whereas over here, water is 2 hydrogens bonded to an oxygen, and so water would be over in pure substance. It's always the same composition, okay? Now we're going to split this further. Pure substances can be split into elements and compounds. Elements and compounds. Okay? So remember, this is kind of like a concept map. It's a flow chart, it's a concept map. Everything we talk about is part of matter. Matter is our central idea here, but now we're splitting it out into further more specific categories. Okay? So elements, definition. It is the simplest form of matter with unique properties. simplest form of matter with unique properties. Okay? They are found on the periodic table. Found on the periodic table, so there's 118 options here. And examples could be carbon, gold, which is Au, oxygen, hydrogen, I mean, pick them. There's 118 of them, okay? But their symbols represent them. All right, compounds. Compounds are two or more elements. Two or more elements bonded to each other in a fixed ratio. Two or more elements bonded to each other in a fixed ratio. Okay, fixed ratio, that's key. So, examples, H2O. Okay, H2O is water. That's a 2-to-1 ratio of hydrogen to oxygen. If I did H2O2, that's a different ratio. It's not water anymore, it's hydrogen peroxide. Okay, so fixed ratio. Same thing here. Carbon dioxide, CO2, we breathe it out all the time. It's all around us. It's totally safe. I mean, we need to breathe oxygen to live, but breathing CO2 doesn't hurt us. Versus CO, carbon monoxide, that's a 1-to-1 ratio, is going to be super toxic to us. Okay? So fixed ratio, if you change the ratio, you get a totally different compound. All right. Splitting our mixtures into two further categories. I'm just going to draw a little squiggle here to make sure we keep these separate. Homogeneous is our first side of this, and our second side is heterogeneous. So these might be new words for you, but homogeneous and heterogeneous, okay? Homogeneous, the definition is it is a uniform mixture, okay? Uniform, which means that it looks the same throughout. Looks the same throughout. Okay, uniform, it looks the same throughout, okay? An example of a uniform mixture could be milk. Okay, why is milk a mixture? Because we can change the percentage of things, we can change how much fat is in it, we can change whether it's chocolate milk or just straight white milk, okay? We're changing what it's made of, we're changing the ratio of things, okay? So it's definitely a mixture, but it's the same throughout. If you take a little tiny bit of milk from this part of the cup or this part of the cup, it's gonna have the same composition, okay? Same percentage of stuff. Steel is another example of a homogeneous mixture, okay? All right, heterogeneous mixture is not uniform. So our last piece, not uniform. And this is going to be examples, could be like granite, so the rocks up at Vitavu have lots of different pieces to them. Another example could be pizza, okay? Lots of mixtures where when you look at the mixture, it's really obvious it's a mixture because it has lots of different pieces to it, okay? So that's the end of those notes.